So this looks like a pretty straightforward antiderivative to take. I am going to start by writing it as a negative exponent. And now I'm using the power rule in reverse. I'm going to add 1 to the -3 and divide by -2 plus c. Now unfortunately I can't find what c is at this point because my initial conditions have nothing to do with the function f prime of x. There's no information about that in these initial conditions. So I can't use them yet. I've got to go one step further and find the actual function or expression for the function. So I'm going to again add 1 to this power, so that's -1, and divide by -1. So there's 2 terms in the denominator there, plus cx. This one has an exponent of 0, so I'm increasing that by 1. And then I also have another integration constant d. Notice I've got 2 different letters for those because they could be 2 different constants. Simplifying this function, I have 1 over 2 to the x. These 2 negatives make a positive, and I'm just writing the negative exponent in the fraction form, plus cx plus d. Now I'm going to apply my conditions, and the conditions are related to the function. So when x is 1, the function is 0. So sorry, I did that correctly. This is when this is equal to 0, when the x equals 1. So I've got 1 over 2 to the times 1 plus c times 1 plus d. So I got 0 equals 1/2 plus c plus d. And that gives me 2 unknowns, so that I can't solve it at the moment, but I do have a second set of conditions. Again, the function is 0 when x is 2. So 1/2, plugging in my x value of 2, and simplifying, I get 0 equals 1/4 plus 2c plus d. So I have equation 1 here and equation 2, so 2 equations with 2 unknowns. And the first thing I'm going to do to each of those is to multiply by the lowest common denominators to get rid of fractions. So in this case I'm going to multiply by 2, and in this one I'm going to multiply by 4. Just think it's easier to look at without the fractions. So the first one, multiplying everything by 2. 2 times 0 is 0, not 2. 2 times 0 is 0, equals 1 plus 2c plus 2d. And doing the same thing with the 4, I have 0 equals 1 plus 8c plus 4d. What that allows me to do is to solve these by addition or subtraction. So I'm going to multiply this one again by 2, and then subtract them. So I get 0 equals 2 plus 4c plus 4d. And if I subtract these, I'm kind of running out of room here. If I subtract these 2 equations, then you'll see that the d's will cancel. I get a 4c out of this. So I'm just going to erase a little bit here to give myself some room. Just trying to think of what to erase. Maybe I'll just erase these initial conditions since we've already used them. So moving up to the top here, maybe I'll do it in red. I have 0 equals -1, so subtracting these 2, plus 4c plus 0. The d's cancelled. So that means c equals 1/4. And once we've got c is equal to 1/4, we can plug that into any one of our equations to figure out what d is. And I'm going to choose this one right here. So I've got 0 plus 1, 0 equals 1/2 plus 1/4, because we know c is a quarter, plus d. So that means d equals -3/4. And that allows us to finally put everything together and get an answer of, where am I going to write that? Maybe I should just erase this right here. These two, we know what C and D are. C was 1/4 and D is -3/4. So my answer for the function looks like this.